The National Electrical Code, or NEC, does not allow the described arrangement of feeding a 1000 amp main circuit breaker section with 3 parallel runs of 4 sets of 350 kc mil conductors. This determination is based on several sections of the NEC. Firstly, NEC 240.4c addresses situations where multiple conductors are used in parallel. This section mandates that the ampacity of these parallel conductors must be adjusted based on both the number of conductors involved and the ambient temperature in which they are installed. In this specific scenario, with 3 conductors running in parallel, the ampacity is reduced by 20%. To calculate the effective ampacity, we start with the ampacity of a single 350 kc mil conductor, which is 310 amps. Multiplying this by 3 for the parallel runs gives us 930 amps. Applying the 20% reduction factor, we get a total ampacity of 744 amps after correction. 3 times 310 amps times 0.8 equals 744 amps. Secondly, NEC 230.42 wireway is crucial for understanding feeder protection. This section stipulates that feeders must be protected against overload by overcurrent devices. These devices must be rated not less than the feeder conductor ampacity or not less than the ampacity of the conductors connected to the terminals of the equipment they supply. In the given situation, the feeder conductor ampacity is 930 amps. Consequently, the overcurrent protection device, typically a circuit breaker or fuses, must be rated for at least 930 amps to comply with code requirements. Thirdly, NEC 230.90 is concerned with the protection of service entrance conductors. This section states that each individual service entrance conductor must be protected by an overcurrent device. In a scenario where there is only one service entrance conductor, it must be protected by a single overcurrent device. Therefore, feeding the 1000 amp main circuit breaker section with 3 parallel runs of 4 sets of 350 kc mil conductors, providing a total of 930 amps, does not meet NEC requirements due to the overcurrent protection requirements outlined above. However, there is an alternative approach that can achieve the desired outcome, and that is replacing the 1000 amp main circuit breaker with a wireway. A wireway is essentially a sheet metal trough used to house and protect electrical wires and cables. NEC 376 provides guidelines for the installation and use of wireways. NEC 376.20 specifies that the sum of the cross-sectional areas of all conductors in a wireway shall not exceed 75% of the interior cross-sectional area of the wireway. This ensures adequate space for heat dissipation and prevents overcrowding. Using a wireway in place of the main circuit breaker can be a compliant solution, but there are some important conditions to consider. NEC 376.23 covers the number of conductors permitted in a wireway. The derating factors specified in NEC 310.15c must be applied to the allowable ampacity of the conductors when the number of current-carrying conductors exceeds 3. This derating is necessary to prevent overheating due to the combined heat generated by multiple conductors in close proximity. NEC 376.21 outlines the permissible uses of wireways. Wireways can be used for exposed work in dry locations or in wet locations if made rain-tight. They must be securely supported and properly grounded. In the situation described, the total ampacity of the 3 sets of 350 kc mil conductors is 930 amps. Assuming that the wireway is appropriately sized and installed according to NEC guidelines, this arrangement could be compliant. However, it is crucial to ensure that the total load on the wireway does not exceed 930 amps. This requires careful load calculations and monitoring to prevent overloading the system. The wireway solution works because there are a total of 6 main disconnects, one for each of the 225 amp meter sockets. With a wireway, the overcurrent protection is provided by the individual 225 amp main circuit breakers for each tenant space, rather than a single 1000 amp main circuit breaker. This complies with the intent of the NEC to protect each feeder with an appropriately sized overcurrent device. Here is a more detailed breakdown of the NEC sections involved. Firstly, regarding NEC 240.4c, This section specifically addresses the protection of conductors. It states that conductors must be protected against overcurrent in accordance with their ampacities as specified in NEC 310.15. When conductors are installed in parallel, their combined ampacity must be used to determine the size of the overcurrent protection. The ampacity of a conductor is determined by its size, insulation type, and the ambient temperature in which it is installed. NEC 310.15 provides tables that list the ampacities of various conductors under different conditions. In the case of 3 parallel runs of 350 kcmil conductors, the ampacity of each conductor is 310 amps, as previously mentioned. When conductors are installed in parallel, the NEC requires that they be the same length, have the same conductor material, be the same size, have the same insulation type, and be terminated in the same manner. This ensures that the current is evenly distributed among the parallel conductors. Secondly, NEC 230.42 ATWO focuses on the size and rating of service entrance conductors. It states that service entrance conductors must have an ampacity that is not less than the sum of the non-continuous loads plus 125% of the continuous loads. Continuous loads are defined as loads that are expected to operate for 3 hours or more at a time. In the case of a meter pack serving multiple tenants, the service entrance conductors must be sized to accommodate the total load of all the tenants. The service entrance conductors must also be protected by an overcurrent device that is rated or set at not more than the ampacity of the conductors. Thirdly, NEC 230.90 is concerned with the overcurrent protection of service entrance conductors. It states that each ungrounded service conductor must have an overcurrent device in series with it that is rated or set at not more than the ampacity of the conductor. The overcurrent device must be located at the point where the service conductors enter the building. This section also allows for the use of service disconnecting means consisting of no more than 6 switches or circuit breakers. If more than 6 switches or circuit breakers are required, a main overcurrent device must be provided. Finally, NEC 376 provides requirements for the installation and use of wireways. Wireways are metal troughs used to enclose and protect electrical conductors. They are typically used in exposed locations, such as in factories and commercial buildings. Wireways must be supported independently of the conductors they contain. The conductors in a wireway must be derated if the number of current-carrying conductors exceeds 30. This derating is required to prevent overheating of the conductors. In summary, the NEC does not allow feeding a 1000 amp main circuit breaker section with 3 parallel runs of 4 sets of 350 kcmil conductors because the overcurrent protection would not be properly sized. However, replacing the 1000 amp main circuit breaker with a wireway can be a compliant solution if the wireway is properly sized and installed, and if the total load on the wireway does not exceed the ampacity of the conductors. Always consult the latest edition of the NEC and local codes for specific requirements and consult with a qualified electrical engineer or inspector to ensure compliance. Regarding the question about whether it would be acceptable if the total load is less than 930 amps, it's still not permissible to use a 1000 amp overcurrent device with conductors rated for less than 1000 amps. The overcurrent device must protect the conductors, and it must be sized appropriately for the conductor ampacity, regardless of the actual load. This is because the overcurrent device is intended to protect against faults and overloads, which can occur even if the normal load is less than the conductor ampacity. In the case of parallel conductors, NEC 310.10H outlines specific requirements. The parallel conductors must be the same length, of the same material, the same size, have the same insulation type, and be terminated in the same manner. This is to ensure that the current is evenly distributed among the parallel conductors. If these requirements are not met, the parallel conductors may not share the current equally, which could lead to overloading of one or more of the conductors. It's also important to consider the available fault currents at the service entrance. The overcurrent devices must have a sufficient interrupting rating to safely interrupt the available fault current. The available fault current can be calculated using engineering methods or obtained from the local utility company. Furthermore, the equipment used in the electrical installation must be listed and labeled for its intended use. This means that the equipment has been tested and certified by a qualified testing laboratory to meet applicable safety standards. Using listed and labeled equipment helps to ensure the safety and reliability of the electrical installation. In addition to the NEC requirements, local codes and regulations may also apply. It's important to check with the local authorities to determine if there are any additional requirements that must be met. In a location of Tampa, Florida, the electrical installations must comply with the Florida Building Code, which incorporates the NEC with some state-specific amendments. It's advisable to consult with a licensed electrical contractor in Tampa to ensure compliance with all applicable codes and regulations. In conclusion, the proposed arrangement of feeding a 1000 amp main circuit breaker section with 3 parallel runs of 4 sets of 350 kc mil conductors is not compliant with the NEC. However, replacing the 1000 amp main circuit breaker with a wireway can be a compliant solution if the wireway is properly sized and installed, and if the total load on the wireway does not exceed the ampacity of the conductors. Always consult the latest edition of the NEC and local codes for specific requirements, and consult with a qualified electrical engineer or inspector to ensure compliance. The key takeaways are: firstly, conductor ampacity must be protected by appropriately sized overcurrent devices. Secondly, parallel conductors must meet specific requirements to ensure equal current sharing. Thirdly, wireways can be used as an alternative to main circuit breakers in certain situations. Fourthly, local codes and regulations may also apply and should be consulted. Fifthly, the electrical equipment must be listed and labeled for its intended use. Understanding and adhering to these principles is essential for ensuring the safety and compliance of electrical installations. Remember to prioritize safety and consult with qualified professionals when working with electrical systems.